Welcome, everyone. Thank you for attending our March Autoimmune Registry Network webinar. And today we're going to take a little different perspective. The Cleveland Clinic's definition of autoimmune disease happens when our body immune system damages our body instead of protecting it.
Yeah, exactly.
So we're looking at it from what happens if the external element impacts our immune system and how does our body react to it. We have the great luxury of having Dr. Cara DeAngelis, the Director of Research for the Global Lyme Alliance, to speak about what her organization is doing regarding autoimmunity. Carrie?
Thanks, Reggie. All right, let me get my screen share. This is always that transition period of screen sharing. Okay, can you all see my screen? Good to go? All right, well, thank you all for being here today and letting me join in this group and talk about Lyme disease and autoimmunity. Happy first day of spring on March 20th. So I think we're all probably excited for that to get started. So I'm gonna run you guys through my agenda. I just wanted to mention I'm getting over a cold. I'm in the middle of it right now, so I'm sorry my nose is a little bit nasally sounding. And I do have two screens, so sometimes I might be looking a little bit off to the side, and I have your faces all up over here. So if you guys see me looking to the side, that's what I'm doing. So to run you through an agenda of what I'll be talking about today is that I'm going to introduce you to, who is Global Lyme Alliance, and what is Lyme disease. I wasn't sure how many of you may be familiar, especially if you're on the West Coast or wherever you're at, you may not have much familiarity with Lyme disease. We'll talk about some of the history around it, as well as the symptoms that you see with it and why we need research in this space. What autoimmunity research has been done, and close out with a nice take-home message, and then we can have some discussion around what I've presented today. So Global Lyme Alliance, or as we call ourselves, GLA, is a leading 501c3 organization dedicated to curing Lyme and other tick-borne diseases through innovative research, awareness, and empowering the patient voice. So this is our mission in a nutshell. And so what I want to point out is innovative research is the core of our mission. This is where all of our dollars go, or most of our dollars go. And as a nonprofit, we rely entirely upon donations to support evidence-driven research. And so this is where I will be spending most of my talk about, but I also wanted to make sure I mentioned, I didn't want to leave off the fact that we do have two other arms to our organization, which is awareness and empowering the patient voice. And what we mean by this is, in awareness, we have a volunteer ambassador program, and we currently have 164 different ambassadors in 38 states and in 5 different countries. And what they do is they volunteer to organize events, share their stories, or give talks and educate the community about what Lyme disease is. And this could be in their universities, the schools, libraries, and things like that. And so that's the awareness element of our organization. And then, as you know, because not everybody has the ability to donate dollars, and it's always nice when people can volunteer their time. And then as for empowering the patient voice, we have a peer-to-peer mentorship program. So anyone who has had Lyme disease or chronic Lyme disease and is going through this and trying to navigate the health landscape, we have mentors who can be matched with mentees and to give them advice. And we also have a Find a Lyme Doctor resource where patients can reach out to reach out on our website and ask for if there are any physicians that may be helpful for them in their area. And in addition, we also have a decent social media presence that creates community within these chronic illness group of patients. And we try to make sure that the patient voice is also incorporated into the funding decisions that we make. And so I'm going to dive now into the innovative research, the part of where my role is at in GLA. So I just want to give just a snapshot overview of our organization. We have dedicated nearly $20 million to support Lyme and tick-borne disease research. And with this donor dollars are, we've supported over 70 different research projects at different academic institutions like Yale and Columbia University and Tufts. And these researchers that we funded have acknowledged us on over 181 different publications. And so I'll talk about a few of those publications here in this presentation today. And so to ensure that we are funding the most promising and innovative research, we have a rigorous grant review process in place that helps us make sure that we're strategically allocating these donor funds into the most impactful projects. So I'm going to walk you through that in the next slide here. So the way that we're advancing Lyme and tick-borne disease research is that we put out a request for applications. We actually are intending to do this in the next few months. We will request a letter of intent. So this is just a one-page document that researchers and physicians can submit saying, you know, this is my research idea. This is what I'd like to do. Here's how much it will cost. And then we will do an internal review of that document. This would include myself and our Chief Scientific Officer, Dr. Armin Aladini, who recently, he's our new Chief Scientific Officer. He joined us in the fall and has over 20 years of experience within Lyme disease research. And he's actually previously been a GLA-funded investigator. And I'm actually presenting some of his research today. And then we also will have, we have a research oversight committee that will help make decisions on to whether we're going to invite a full proposal or not. And so full proposals, if you're familiar with the NIH, there's R21 style grant applications. We have researchers submit a 6-page proposal about their project. And then what we'll do is have our scientific advisory board review and critique those proposals based off of an NIH style review process. So our scientific advisory board members are key opinion leaders within the Lyme and tick-borne disease space. They will go through and critique these proposals on a 1 to 9 scale on their significance, their approach, their innovation. The investigator, they'll go through and check the milestones and make sure that the budget is in line. And after that review, we will take this back internally with our research oversight committee and strategically determine which projects we should be funding. And so then as a nonprofit organization, we'll then take this to our board of directors and get that final approval of what we want to fund. And then we have research funded. And so that's the exciting part. And that's when we're starting to make differences in the field. And so why do we need research in Lyme and tick-borne diseases? So I'm going to give you guys a little background on that. So for some history, for some Lyme disease history, if you guys are not familiar with this, in 1975, so 50 years ago, there was this cluster of juvenile rheumatoid arthritis cases in Lyme, Connecticut. So that's actually an hour north of me right now, and some of you may be close to this area as well. And this cluster of cases was really bizarre. It was in otherwise healthy children. And this, as this group, I assume, knows that, you know, rheumatoid arthritis is an autoimmune disease, and it was happening approximately 100 times more the estimated prevalence of rheumatoid arthritis in these communities. And so these parents, these two mothers came forward and sounded the alarm to the public health, and were like, what is going on? And it wasn't just in children, it was in some of the family members as well, some of the adults. And what was happening was it was in these 3 communities of East Haddam, Lyme, and Old Lyme, and it was all on this east side of the Connecticut River, and it was happening. There were even like a number of cases that were on the same street. And so this epidemiological profile of juvenile arthritis, juvenile rheumatoid arthritis did not fit. And so then this is when they embarked upon, you know, looking into this further. And it turned out that these patients who had these swellings in their knees and other arthritis, there was this really seasonal pattern where they would see these swollen knees show up, especially in the summer and the fall. And so because of this geographic, seasonal, and familial clustering that they were seeing, it was really suggested that, you know, it's likely not juvenile arthritis, juvenile rheumatoid arthritis, it's something else. And so then this led to several years of investigation into this, and they discovered that Lyme disease was actually caused by a bacteria called Borrelia burgdorferi, and it's transmitted through the bite of an infected black-legged tick, which is also known as deer ticks. And so it turns out that on this side of the river, there were a lot more of these ticks, and they were biting people and transmitting this pathogen. So I'm going to go a little bit into the tick life cycle to explain to you guys why we were seeing this summer-fall cycle of disease. So with ticks, the tick that causes, as I mentioned, a deer tick or a black-legged tick, the scientific name is Ixodes scapularis. They have a 2-year life cycle in which they will then pass through 3 different stages. They have a larval stage, a nymph stage, and an adult stage. And in order to grow and molt into the next stage, they have to take a blood meal. And so what happens is that these eggs are laid in the spring, they'll hatch into larvae. These larvae will then take a blood meal from usually a small mammal, such as a mouse, maybe even a bird. And then over winter, then they will molt and turn into nymphs. And these nymphs are very small. They are about the size of a poppy seed. And so what they'll then do is latch on to, again, small mammals, birds, and they also can end up on deer and humans. And this is the nymphal stage, is the stage that is most likely to transmit Lyme disease just because of especially how small it is. It's very difficult for people to be able to find them. And then after they've taken that blood meal, they will drop off and they molt into an adult, in which at that time they will then feed on larger hosts, especially deer, which is why they're called deer tick. They really prefer deer. And those female adults will then lay eggs and the cycle will continue. And so I just wanted to make sure you all had an appreciation for this cycle that they have. It's really when Lyme disease is you need to be very careful about it all year round, but especially in the spring to summer months. As you can see, that's when these ticks are mostly active. But now that we've explored the life cycle of a tick and how it plays this really crucial role in transmission of Lyme disease, I wanted to take a little bit of a closer look at how the spread of Lyme disease has evolved over time and this growing number of cases that we're seeing. So Lyme disease right now is the most common tick-borne disease in North America and Europe. It's also in Asia as well. For this talk today, mostly I'm focusing on the United States. And it's estimated that 476,000 people are diagnosed with Lyme disease in the US per year. And so I wanted you to take a look at the maps that I have over here. In 1996, we had each little blue dot here represents one reported case. These are maps from the CDC. And this is surveillance data showing all these different Lyme disease cases. And you can see it was mostly in the New England area and these upper Midwestern states, and occasional cases here and there throughout the US. But then in 2023, you can see that this has really exploded. They've started to move south. They're starting to expand more. Canada is seeing more cases. We're seeing those in Florida as well. And so because Lyme disease is continuing to spread, it's really important to raise this awareness of its symptoms. One of the things about it is that it's known as the great imitator. It can mimic other conditions, making early detection very challenging. And so with more people being diagnosed each year, it's really important that patients and healthcare providers recognize signs of Lyme disease. So I'm going to go through some symptoms of Lyme disease. So, next slide. Here we go. So after a tick has latched on, usually they will feed for 3 to 4 days, up to 5 days. And usually after around the 48 to 72 hour period is when the Lyme disease bacteria can be transmitted. And then after the tick drops off, within those first few days to first weeks of infection, the symptoms will be fever, headache, fatigue. So this is that great imitator. You could think that you have the flu. You may not realize what's going on. And then there's also a characteristic skin rash called an erythema migrans, or an EM rash that resembles a bullseye. And so here's an image of a classical EM rash. And you can see that there's, it looks like the target symbol. So this is very characteristic, but unfortunately not everybody develops a very classic bullseye rash like this. Sometimes it's atypical looking. It may not have this clearance. Some people, you know, with darker skin color, it's going to present differently on their skin. And in addition, some people may never find the rash. Ticks, especially, you know, these ticks like to go to warm, moist places on the body. They can go to the groin or the back of the knee, and a lot of times up in the back of the head along the scalp. And so you may just never see a rash develop because it could be under your hair or you didn't look behind your knee. So sometimes this can really be missed. And if that happens, and or you think, you know, I just got the flu, I'm not going to get antibiotics or go to the doctor, it'll be okay in a couple days. The disease can, the bacteria will disseminate into what we call the second stage, where weeks into months after infection, they will then spread to the rest of your body, including the heart, your brain, and or joints. And then after that, we have what we call late dissemination phase, whereas in weeks to even months after infection, usually with around 6 months after infection, patients will start to see chronic arthritis, specifically, usually in a knee, one knee and not the other. And so you know, this looks very clear cut, you know, that there's this 3 stages, but I want to share that the patient landscape can be a lot more complex. So I just shared, you know, that this Lyme disease, there's stages 1 to 3 with early disseminated, and late. As a bacterial disease, it is treatable with antibiotics. So doxycycline is the first line antibiotic for Lyme disease, and about 80 to 90% of individuals will return to health. And so, you know, 8 out of 9 to 10 people, they get bit by a tick, they have a rash, they feel crummy for a couple of days, they get their antibiotics, and they go back to normal. However, there's 10 to 20% of individuals who go on to continuing to have these really subjective constellation of symptoms. It's fatigue, cognitive difficulties, brain fog, musculoskeletal pain, and they have a lot of, you know, and because it's subjective, it's really difficult. You can't really measure that except for with surveys. And so in this group has been termed the post-treatment Lyme disease syndrome group. This means that after 6 months after they received antibiotics for Lyme disease, 6 months later, they are still having symptoms, in which these can be a range for a number of people. Sometimes it can just be, you know, a mild annoyance, and others it completely destroys their quality of life and they lose their jobs. And this is really problematic. And this also can be termed as chronic Lyme disease. And the thing that is happening here is we don't know why these patients are going on to have these continued symptoms. And I also want to mention that there's another group of patients that we also can call chronic Lyme disease, that maybe they never saw a physician early on. They never were diagnosed with Lyme disease early on. They didn't receive antibiotics. And they show up later and they're bouncing around the healthcare system and they're trying to figure out what's going on. And the challenge that we're having with this today is that we're seeing a lot of infection-associated chronic illnesses that have very similar patterns of disease, so and symptoms. So as everybody here has seen with the COVID-19 pandemic 5 years ago, you have this infection that first starts, and then you have this associated chronic illness that continues afterwards, where you have these similar symptoms of fatigue, cognitive brain fog, and musculoskeletal pain. And how do you, if you have someone who is presenting with these symptoms, how do you determine if they have long COVID or chronic Lyme disease or long Lyme or Lyme infection associated chronic illness? There have been very many number of names that have been used for chronic Lyme disease. And then there's also, you know, fibromyalgia, ME/CSF, MS, and making sure that people are not misdiagnosed is a challenge. And so in the diagnostic landscape for Lyme disease, the reason why we have these diagnostic challenges is that this bacteria, the diagnostic tests we have for it are antibody based. And so early in disease, when you first show up with a rash, sometimes you may not show up as on lab tests, you may not show up as positive because your body hasn't had time yet to develop antibodies. However, later in disease and early disseminated and late, those tests do work pretty well at detecting those who have had Lyme disease. The challenge then becomes is some of these antibodies can last up to 20 years. And so say you get reinfected later, these antibody tests have no way of detecting prior or active infection. And the other challenge is that we don't have very great direct detection methods for Lyme disease bacteria because it's very it doesn't last in the blood for very long. It goes into the tissues, and it's in very low numbers in comparison to what we see with other bacteria. And so this leads to this very challenging diagnostic landscape where we don't have any tests for long COVID either. So how do these physicians determine what to do with these patients? And so that's why Global Lyme Alliance was formed, for understanding what is going on in these patients groups who continue to have this symptomatology. They received antibiotics, but they're not recovering. And so our goal of our organization and our research program is to start understanding the mechanisms behind this. Why is this happening? To develop better diagnostics, to understand if we can catch people earlier in disease and make sure that they don't go into this developing a later stage, more chronic illness, and then also to detect it apart from other different infection-associated chronic illnesses, and then also to make better treatments and make sure that these patients have something that they can do to help with these symptoms that they're experiencing. And it would also be great to have a diagnostic test that allows us to examine treatment efficacy. If patients are taking a treatment that we're trying to assess how well it's working, it would be great to be able to detect that. So now I'm going to go into, sorry, did somebody have a question? No? Okay. So going into the next slide, I'm going to talk a little bit about the hypotheses behind what could be happening here. And so one of the main hypotheses that we have is that there's this immune system dysregulation that's occurring. This could be infection-induced chronic inflammation, an autoimmune response. And so that's why we're going to spend a lot more on the next few slides and this circle right here. But there could be microbiological factors involved. So some recent research done by one of our GLA-funded grantees has shown that there can be some remnants left behind from the Lyme disease bacteria that may be continuing to cause this continued inflammation. There is the theory that there could be persistent infection still in some cases. And then there's also other tick-borne infections. So ticks can carry other diseases, other bacteria and viruses, and could transmit other pathogens. And then some types of Lyme disease bacteria are can cause more severe disease than others. And then there's another theory of neural network alterations, that the central nervous system can become really inflamed. And there can be this issue where patients are overly sensitive to pain and other stimuli. And then there are other factors, of course, the host genetic and environmental factors. So host factors here, some people can be genetically predisposed to respond to infections differently than others. And, you have the effect of, whether you're a child or an older adult or a man or a woman. So we have all of those different factors that come into play. And then we also have the illness experience factors that go into this, of maybe patients had their treatment delayed and maybe their illness was invalidated. A lot of patients with chronic illness go into their physicians and they are told that it's all in their head. And so that leads to more stress and can perpetuate this cycle. And so what I want to emphasize here is that these are all hypotheses. There's some evidence. Evidence is really heavily weighting towards immune system dysregulation, but when we consider what is likely happening here, it's probably a spectrum of all of these factors contributing in some way, shape, or form. It will probably never be just one mechanism. So now I'm going to talk a little bit about antibiotic refractory Lyme arthritis. It is the most well-characterized subgroup of patients that have post-treatment symptoms and connections to autoimmune diseases. So I'm going to walk you guys through this graph here. On the x-axis down here, we're looking at time. So this is over time, what's happening with these patients. And then on the y-axis, we're looking at the degree of inflammation that they're experiencing. And so what happens at first is these patients have their tick bite, and they have some joint pain that eventually then begins to develop. It starts to swell, and you get a lot of fluid buildup, and they go to the doctor and they get antibiotics. And what happens at this stage is the dashed line here is the antibiotic responsive. These are patients who respond well to antibiotics. The swelling goes down, they return back to normal. And then the solid line here is what we're calling this antibiotic refractory group. And they do not respond well to antibiotics. And what happens is that these patients actually respond well to DMARDs, which I assume this group may be somewhat familiar with, these disease-modifying anti-rheumatic drugs, which are more given out to patients with autoimmune disorders. And so patients can also have synovectomies where they go in and clear out the joint to try to help with this inflammation. And so what happens over time, though, is even without, sometimes in patients who haven't even received treatment, the arthritis will resolve over time. So what's happening here is that at this first stage with the tick bite, some of these patients could maybe have been infected with a Lyme disease bacterial strain that maybe causes more severe disease and has been associated with arthritis. And then after antibiotics, though, they have not been able to detect bacteria in these patients at all. But as I mentioned a little bit earlier, there have been some remnants of bacteria left behind. And so there's this question of, can those particles in some patients still continue to drive this inflammation? And what happens is then this continued overloaded immune response suppresses wound healing. And so then with this very large inflammatory response, we have vascular damage that occurs in these arthritis patients. These fibroblasts will really grow. The joint will then thicken, leading to pain, swelling, and stiffness. And this continued inflammation also can lead to autoantibodies. And there also is the potential for genetics to play, in which some patients may be at a higher likelihood of developing potentially autoantibodies. And so this creates this very large inflammatory cycle in these patients that looks similar to an autoimmune disorder. And that's really actually this arthritis that's seen in these patients is very similar to rheumatoid arthritis, except for the vascular damage in Lyme arthritis is unique to that. And as I mentioned, though, in contrast to rheumatoid arthritis, post-infectious Lyme arthritis eventually resolves in all patients. It just may take up to 5 years or longer for some patients to see resolution of their arthritis. So I want to take a little bit of a closer look into the inflammation in these patients, as well as those who have post-treatment Lyme disease syndrome. So C-reactive protein, it's a broad marker that reflects presence of inflammation. So as I'm getting over, I'm in the middle of a cold right now. My CRP is probably a little bit mildly elevated as well. But it's a biomarker that you can look at to measure, what type of inflammation is happening. And I want to run you through this graph here really quick. I promise I don't have many slides with data like this. This is actually funded by Global Lyme Alliance, and this research was done by Dr. Armin Aladini, who's now our Chief Scientific Officer. But when they did this work, they were looking at, on the y-axis here, we're looking at the inflammation as we're measuring this through the CRP protein. And then we're looking at the healthy controls. So each dot here represents an individual patient, and the red line is the average of their C-reactive protein level. And we're looking at this in their blood, and these healthy controls have this lower level of CRP, as you would hope to see. They don't have inflammation going on. And then we can look at, as the disease progresses, so this is single EM, so this is the erythema migrans lesion. So this is the early stage of disease. And then there's multiple lesions that can occur that shows that the disease has disseminated. And then neuroborreliosis, early and late, is also later stage disease. And arthritis is further into the disease. And so what we're seeing here is over time as the disease progresses, what does this inflammatory marker do? And so you can see at the very beginning, there's this increase in CRP in response to the pathogen. But as the immune response comes forward and we create antibodies, that will then die down. And even in those patients who have, this is looking at the group of patients who have responded to antibiotics with their arthritis, they return to baseline levels. And this refractory arthritis, this is the group that has post-infectious Lyme arthritis, they have a statistically significant, that's what these little stars here mean, they're statistically significant than these other groups in the healthy controls. So they are actively having this inflammation going on in these patients. And I also want to talk a little bit about these post-treatment Lyme disease patients that I mentioned earlier who have these constellation of subjective symptoms. These are post-treatment Lyme disease patients who returned to healthy. So they had Lyme disease, they returned to health, and then these are patients who went on to have symptoms. And you can see here that statistically speaking, these patients have higher levels of this inflammation going on. So it's not in their head, something is happening. This is an actual biomarker that's showing that these patients have more inflammation going on in their bodies. And so what's happening here is in this post-infectious Lyme arthritis and in post-treatment Lyme disease syndrome patients, we have this elevated CRP, but it's likely due to immune system dysregulation, not due to direct presence of bacteria. So I want to talk a little bit more about this PTLDS group. So this is my last data slide. This post-treatment Lyme disease group, because they have this brain fog, there's a lot of questions around, well, what is going on in the brain? What could be causing these symptoms? And so we've had researchers looking at serum samples from these post-treatment Lyme disease patients, as well as those who return to health, normal controls, and lupus patients as well, to see if they have antibodies that are against brain matter. And so you can see on this graph here on the y-axis, we're looking at this antibiotic reactivity to brains, and this post-treatment, oh, my mouse just froze. Okay, this post-treatment, here we go. Oh no, it doesn't want me to point. Let's see. Here we go. Okay, it's back online. So this post-treatment Lyme disease group, you can see that there's this increased activity to neural proteins, whereas the patients that return back to health or who have never experienced Lyme disease don't have this really increased large amount of reactivity towards neural proteins, whereas those patients who also have lupus, another autoimmune disease, do have this increased amount of antibodies to neural proteins. And so the thing is, though, that these may be heightened antibodies, but they're non-specific. And so the challenge is here, we don't know yet if these autoantibodies are actually causing chronic manifestations of Lyme disease. We can't say yet that this causes brain fog or anything like that. No connections have been made. So with that, I'm going to wrap up my presentation just a little bit, but before I close out, I wanted to talk about some of the research that GLA is currently funding and the connections that it has to autoimmunity. And so I've mentioned this grantee a few times. One of our grantees is Dr. Brandon Jutras. He's actually pictured over here at Northwestern University, is looking at a unique biomarker from Borrelia, the Lyme disease bacteria, called peptidoglycan. It's a part of the bacterial cell wall, and they've been able to find this in patients' synovial fluid in their knees with their arthritis, and they're able to actually inject this biomarker peptidoglycan into mice, and it causes them arthritis. And so it's really been linked to causing this continued inflammation. And so because of this, it has a lot of potential as a biomarker for diagnostics, where we may be able to identify this lingering biomarker in these joints, or see if it's circulating in the blood, as well as urine. And then it also could be a treatment target, because if it's driving this inflammation, if we could manage to remove it, then we could hopefully help with some of these symptoms that patients are having. Another one of our grantees is really investigating the inflammatory response in patients with PTLDS. So they are looking at overlaps with other infections. So for example, they're looking at patient samples from patients with COVID as well as tick-borne encephalitis. And what you can see is that there's this major symptom overlap in these patients, and they want to see what types of inflammatory markers might be shared between these different groups. And then also looking at the role of genetics in these patients. So some patients may be predisposed to having this more aberrant, very large inflammatory response at the start of infection. And is that possible that that's shared across these different patient groups? And then in addition, I just wanted to mention that we're supporting 2 different biobanks. One is a European biobank as well as a pediatric Lyme disease biobank that are collecting samples from patients. And this really provides essential resources to support researchers so they can do further research and determine, what's going on in these patients, develop better diagnostics as well as treatments. And so with that, I want to just leave you all with, before we jump into discussion, a take-home message that Lyme disease is not an autoimmune disease, but an infectious disease. So at the very start, those patients who return to health and get antibiotics, there's no autoimmunity involved in those patients. However, there's this evidence for autoimmunity in patients who develop post-infectious Lyme arthritis, this really well-studied group of patients. We see the elevated inflammation with C-reactive protein. We see a lot of other inflammation that then drives this formation of autoantibodies in these patients and vascular damage. And this treatment of this arthritis usually is helped with DMARDs. And so it's not what you would call a classical autoimmune disorder, but it is more of a post-infectious immune-mediated condition. And then for the subset of patients with infection-associated chronic symptoms, there's the fatigue and brain fog. The pathology behind that is really unknown at this time. And it could be due to, as I went through some of those hypotheses, this overactive immune response. Maybe some are genetically predisposed to have more of an autoimmune response. Maybe there's bacterial remnants that are left behind that continue to drive this. And maybe there are other factors that we haven't discovered yet today. So with that, I kind of just wanted to wrap up with, if you end up having arthritis, it's really important, to see a physician that is able, especially if you're in an endemic area, to make sure that you also consider Lyme disease as a potential reason for why you're experiencing that. So with that, I figured we could open up things for some discussion. And I was really curious about some of you all, what organizations you're from. And I know that there's a lot of hypotheses around if autoimmune diseases are triggered by infections. And I was curious to see what autoimmune diseases you all represent. And yeah, so.
So we see some questions in the chat.
In the chat.
Yeah, so would you mind if I call on you, Patty? Do you want to introduce yourself and ask your question? Okay. How about?
Can you hear me?
Oh, sorry.
Can you hear me?
Yes, go ahead. Sorry.
Okay. Yeah, you talked about testing not being effective for the chronic. My question is, what are your thoughts about the genetics tests and the virus tests, which supposedly are able to find the results with the chronic individuals?
Right. So as of right now, I'm not very familiar with Vibrant, but for iGenix, that company, I have been looking to dive into some of their specificity and sensitivity with their diagnostics. The challenge is that they do have different criteria on some of their tests where they loosen some of the criteria for whether someone is diagnosed for Lyme disease or not. And so that can lead to potentially some more broader catching of Lyme disease cases, and they could be false positive. But thank you for your question, Patty.
We also have a comment from Katrina. Katrina, did you want to speak on your question?
Oh, sure. Firstly, thank you so much. It's really, really interesting. I am the CEO of the Pernicious Anemia Society, which is an autoimmune condition. And why I was particularly interested is that we have a lot of people who come to us who have initially had a diagnosis of Lyme disease or been misdiagnosed, because there's a lot of overlap of symptoms, brain fog, fatigue, all that sort of thing. And it's an area I think really would be ripe for further research, because we sort of know or think, but it would be good to be able to prove that some type of trauma infection is a trigger for pernicious anemia. And so, for example, H. pylori bacteria, Lyme disease, long COVID potentially, COVID generally. So yeah, it's something that I think would be really interesting for further research. It'd be nice maybe offline to talk to you more about that, because yeah, something that I think a lot of people would be, particularly because there's such a sort of overlap. People with pernicious anemia often have hypothyroidism. So there's a lot of overlap, as we know, with autoimmune conditions, and we just don't know sometimes why these things happen. But we do know, of course, that B12 helps people with autoimmune conditions. And I know also one of my colleagues, for example, had Lyme disease and relies very heavily on B12 to manage her symptoms.
Well, thanks. I'm really glad you brought that up, because I'm not familiar with Lyme disease patients showing up with pernicious anemia afterwards. And so I'm glad you mentioned that, and I'll look into the literature a little bit more about.
Yeah, I mean, it'd be great, maybe just, I mean, also maybe some further research as well in the future. It would be good to know if any of your patients do end up with it. It's a very difficult condition to diagnose. So, a lot of people end up having to sort of self-diagnose and self-treat, and may have been on a long journey of trying to find a solution for themselves, because they've have a leftover or hangover of symptoms and conditions, which may be that, because one of the issues with autoimmune conditions, I don't know if other people feel the same, is that once you've been labeled with an autoimmune condition, it's easy to sort of keep sort of focusing on that and not look wider. We know, for example, that many people get a diagnosis of fibromyalgia, which actually isn't a condition. It's just a bunch of symptoms. But once they've got that label, they seem quite happy to live with it. But that isn't actually what's wrong with them.
Good
Sorry,
point,
I just suddenly got on my soapbox, and
That's a really good
I don't
point.
know why.
Not a problem. Tony, you have a question?
Yeah, Katrina, your last point, I totally agree. So I chair Bechet's UK, and Cara, thank you for that brief. It was fascinating. And to answer your question, yes, indeed. I'm just searching for the thing I Googled quickly. It was Hippocrates of Kos, 460 to 377 BC, that first described or characterized Bechet's. And lots of research papers keep talking about environmental factors and particularly some sort of virus. And if you look at, for instance, long COVID symptoms, a lot of the things that happen there with the body randomly affecting all kinds of things is the sort of thing that goes on with Bechet's. So there's now, I'm quite sure there could be long-term sort of issues that bubble up in all kinds of different ways. I was going to say, I don't know whether you've come across a chap called John Caldwell, who I'll put a link in the chat. So he's a very rich chap, made his money in phones and stuff. I just happen to know of him via my children's school, fun enough, primary school. He, like a lot of societies and charities and things, there's lots of different ones for various reasons spring up about the place. But he certainly, one, got a lot of dosh, and two, is interested in research. So I'll just put the link in the thing there, because I think it might be useful for yourselves to sort of link up with them. There's often you get this sort of siloed approach to research, and it's the way, in England, UK, the research, what's called the research exercise framework, which doshes out 2 billion quid's worth of money to universities is all based on peer-reviewed papers. And as a consequence, it makes everyone very secretive and they do their own thing, and you suddenly then see a load of research. And I think that's a similar characteristic internationally for different reasons and different way things are done. And it's really important. That's what I think. This is why I joined this group. I think they're fantastic at spreading the word about various conditions, diseases and things. And I definitely agree with what Katrina said about once you get a label, that's sort of it. Now, on the one hand, for rare disease patients, it's really important to try and give them a label because they flounder around for 5, 6, 7, 10 years, not knowing what's going on, bouncing around from one person to the next. And once they get a label, at least psychologically, they say, right, well, there may be no cure, but I know what it is, and I know what to do. And of course, they then self-advocate a lot, do lots of research themselves, and know more often than the GPs they see, because, you know, a GP can't understandably know 8,000 rare diseases sort of thing. So anyway, thank you. I thought your presentation was fantastic.
Thanks, Tony. I do see Patty has another question about other tick-borne infections such as Babesia, if we're doing research in that space as well. We did have a grantee at Yale University, Shukri Ben-Mamoon, who is doing research on babesiosis. So for you guys who may not be familiar with it, it's another tick-borne pathogen that is a parasite. It's very similar to malaria. And so what it does is it will infect red blood cells and break them open, and you can have Lyme disease and babesiosis at the same time. And the thing is, because it's a parasite, you can't treat it with antibiotics. So it's really important to get that diagnosis so you can get a different treatment for these patients, and anti-parasitic treatments. And it's not really all that common to happen, but it's not, you know, it's not rare. You do see a number of cases in the US where people will be co-infected with both tick-borne infections. And so our researcher, when we were funding him, he was working on another diagnostic. So the pathogen Babesia microti is the one that causes most of babesiosis in the United States, whereas there's another one on the West Coast called Babesia duncani. And this one, it may be underdiagnosed, and so he was working on a diagnostic test for that, as well as coming up with some different combination therapies that may help with these patients who have babesiosis. So we are looking into some other tick-borne infections.
Very well said, Carrie. Any additional questions?
Oh, hi, this is Ken. Thank you, Cara, for presenting today. I have a quick question about data sharing. And I think, I know you managed a very powerful research grant program regarding global research, because as we know that the patient is, you know, they are in different countries, so especially for your alliance. So how do you coordinate if you need to work with multiple investigators on a team project? Where they have patient cohort in different continent even. Could you comment on that? Do you pull data somehow together?
So usually at this point in time, I've been with Global Lyme Alliance for 3 years, and I've had, like, for example, the biobank that we're funding by Lise Negrovich. She has a biobank out of Boston Children's Hospital, and it's a network of 8 different emergency departments across the US. And as for how they do their data sharing, that's all within themselves. So we haven't helped with how they collect their data. But we do have, for this European Biobank initiative that we're launching at this symposium. I was just at a symposium last week where I got to meet them. And we're planning to pull a Zoom meeting together to bring together them. And we also have an annual research symposium in 2 weeks where we bring in a lot of our grantees. It's a closed door symposium. And we're planning to have a discussion there where we talk about the standardization of sample collection and making sure that there's where we, you know, a lot of it is connecting researchers to each other and making sure they can share their resources together, and that if someone's collecting their serum samples this way and storing them this way and aliquoting them out for, you know, diagnostic this way, that's how they'll do things. So most of the time we assist and we try to help connect researchers as much as we can, but we don't have like a cloud or a large data sharing space where collaborators work together.
I see it. And so it sounds like, at least for now, the US and European research group are working on their own, and there might be a movement to help them to be more interoperable with each other in terms of how they collect sample. Is that
Yes,
is that right?
the European Biobank, we're just starting. I'm actually working with the university right now to try to get the contract in place. So it hasn't kicked off yet. So that's something that we're working on. And then in addition, we do have, so for example, I mentioned Clemens Sturla. He's one of our investigators. His father is in Slovenia as a physician, and they collaborate together a lot. So we have a lot of interconnectedness with our researchers, and we did have a really large study that came out in 2021, a nationwide Danish study showing that Lyme disease is more likely to be, patients who have had Lyme disease are more likely to have suicidal thoughts, as well as anxiety and depression. And so that was a collaboration between Columbia University and Copenhagen University. So we have some collaboration around, putting the Global Lyme Alliance. But we're working on expanding out and making sure that we're funding the best research that we can.
Yeah, if I may have one tiny follow-up, which is about, I think standardizing sample collection is a very important step, a foundation. For the data I already have, though, so because from the U.S. Health and Human Services view, that once your health data is de-identified, then it's no longer considered as human subjects. So wonder, in your experience, does that work similarly in the European or Latin America? Or because I was thinking about, at least for now, there might be some core data elements that can be viewed together, but sometimes that involves data sharing with a safety procedure in place. Could you comment about the data part in addition to the sample collection?
Yeah, that's a really good point, and I'm glad you brought it up. And I'm not familiar with some of those differences in data sharing within Europe and how they do that de-identification and all that process. So that's something I'll have to look into. And I'm sorry, I don't have an answer for you.
Oh no, thanks for attempting to help me. Really appreciate your presentation today.
Were you at the NASM conference like 2 years ago on infection-associated chronic illnesses by chance?
So I was not, but it really there's it is inspired by that. But my mentor, the previous CEO, was on that committee, and that's why I've been receiving a lot of teaching from him.
Okay, great.
Wonderful questions.
I have a quick question too. I have an organization that helps collect data for researchers, patient data, and Tim is actually one of our scientific advisors. And so, I'd love to connect at some time in the next couple of weeks, Cara. It could be something useful for some researchers that are looking for a way to collect data and provide assessments to patients. And we focus on all of the IACCs that have prevalent mental health types of symptoms, and they're getting treated incorrectly because it's typically inflammation driven. And so we're just getting started with our platform, which we took over a part of a platform from another organization. We haven't announced it yet, so I can't tell too much about it, but we do provide a lot of things for researchers that might be helpful in your space. And then they could have their biobanking samples attached to the patients, but we don't do the biobanking ourselves. So that would be something, with your biobank that you fund, we could work with that piece of it. But I'd love to connect, and you could talk with our principal investigator and learn a little bit more.
Yeah, that sounds great. Thank you, Christy. I think that, collaboration, as Katrina and Tony mentioned earlier, a lot of these patients, go around. I think everybody in this group has experiences where patients go around and aren't getting their diagnosis. And I think collaboration, instead of working in silos, is the best way.
Yeah, definitely. That's really the core of what we do. And we want to have open access data, so a lot of researchers are able to use it. But, realizing that one organization can't do it all themselves. And so we just help with the piece that researchers might struggle with, coming up with the best outcomes or the right protocol or questions to ask patients and all of those different pieces. That's something that we focus on.
That's great. So I just put my email in the chat. Our organization, hopefully I spelled that correctly. I'm sure Reggie, if you guys need my email, you can always reach out to Reggie, right, Reggie, and then get my email from him as well. And I think I probably showed up in the calendar invite today as one of the emails listed there. Our office is completely virtual at this point in time, so we don't really have office numbers, but definitely happy to connect over email as well as have Zoom meetings.
Yes, we'll make a point of having that communicated. As normal, we are out of time now, so I have to wrap up. But as usual, our webinar will be posted on our website. And Carrie, wonderful job, wonderful job.
Thanks, Reggie.
Learned so much from your presentation today. With that, thank you for attending today, and we're looking forward to seeing everyone next month. Have a great day.
All.
Bye. Thank you, Cara.